Introduction to roots and radicals. A radical expression is an expression involving the root symbol, which is called the radical. Now, the value under the radical sign is called the radicand. In the example below, 8 is the radicand. The index of a radical expression must always be a positive integer greater than 1. And the index is the little number that's on the outer of the radical symbol. So again, that must be a positive number, and it must be a number greater than 1. Now, when you see a radical with no index on the outside, such as in the second example, it is assumed to be 2, so therefore anytime you see a radical symbol with no number on the outer, that means that you are dealing with a square root. Learning objective number 1, to find the principal square root of a number. For every operation, there is an opposite that can be used to cancel the operation or to make it equal to 0. For example, the opposite of addition is subtraction. The opposite of multiplication is division. And the opposite of squaring a number is to find the square root of a number. For example, 3 squared means 3 times 3. 3 squared equals 9. If you take the number 9, the answer, and do the opposite, work backwards, you take the square root of 9 and you're saying what number, when I multiply it twice, will equal 9? Well, that number is 3. 3 is the only number when you square it will equal 9. So they are reverses of each other. When you're dealing with square root, just think of it is some number squared. So again, the square root of a number are numbers which, when squared, are equal to the original number. So in this case, the original number is 16, and square root of 16, I'm looking for some number that, when squared, will equal 16. So you should know by now that that would equal 4. Square root of 16 is 4. And we know that because if you square 4, you're going to get the original number of 16. Now, positive square roots, perfect square roots, they have both actually 2 roots, because if you take negative 4 and you square negative 4, you're also going to get 16 as well. So therefore, the square root of 16 is both 4 and negative 4. Now, when we speak of the positive of the root, then we call that the principal root. For example, the square root of 9 we know to be as 3. So this is what we would consider to be the principal root. Now, when you include both the positive and the negative, the 2 square roots, many times it is written as such. You see here with the what you call plus or minus symbol. So plus or minus square root of 4. So you want both the negative and the positive of that. Now we know the square root of 4 is 2, so it would equal plus or minus 2 which means the same thing as both solutions, -2 and +2. How do you know you have a perfect square? Well, any number whose square root equals a whole number is called a perfect square. For example, 25 is a perfect square because if you take the square root of that, the square root of 25, it does equal 5, and 5 is a whole number. So anytime it equals a whole number, then it is called a perfect square. Here are some examples of some perfect squares: 0, 1, 4, 9, 16, and so forth. These are numbers that if we take the square root of them, they will equal a whole number. Now let's do some practice with perfect square roots. And I just want to make a note that from this point forward in this chapter, when we ask for square roots, we are referring to the principal square root, which is just simply give the positive number. So the square root of 64, what does that equal? If you said 8, that is correct. How about the square root of 100? Good, 10. Square root of 36? You got it, 6. Square root of 144? That's correct, 12. Square root of 81? 9. And last one, square root of 121? 11. Good job. There you have it. Practice with perfect roots. Okay, let's do some practice square roots with fractions, and don't let fractions scare you. You got this. The first example, the square root of 9/16. All you have to do is take the square root of the numerator and then take the square root of the denominator and write it as a fraction without the radical symbol. So what is the square root of 9? That's correct, 3. What is the square root of 16? That's correct, 4. So what you have is a fraction of 3/4. And again, we're asking what number, when we multiply it twice, will equal 9/16. And that number is 3/4, because 3/4 times 3/4, if you multiply the top 3 times 3, it equals 9. The bottom 4 times 4 does equal 16. So therefore, again, the answer is 3/4. So what is the square root of 64 over 81? If you said 8/9, that is correct, because that is the only number, when you square it, will equal our original number under the radical, 64 over 81. So our answer is 8/9, because 8/9 squared equals 64 over 81. What is the square root of 100 over 121? Again, we want to know what number, when we square it, will equal 100 over 121. If you said 10/11, that is correct, because when you square 10/11, 10 times 10 is 100, 11 times 11 is 121. So therefore, again, the answer, the square root of 100 over 121 equals 10 over 11. In learning objective number 2, we want to find the negative square root of a number. Now, the radical sign with a negative in front of it is used to denote the negative square root. Now we know that the square root of 64 is 8. However, if we write that same expression but put a negative in front of it, what we're doing is negating it, which means I want the very opposite of 8. Because in this example, it equals 8. If we put a negative in front of it, we want the opposite of 8, which would be negative 8. So that is why the negative square root of 64 equals negative 8. Okay, so again, anytime you see the negative outside the radical symbol, you're just simply negating your answer. It's always going to be the very opposite of that number, the additive inverse of that number. Okay, so what if you have the negative underneath the radical symbol? This time it's not outside, but rather it's inside. When you have it inside under the radical symbol, you have to think of it as simply finding the square root of it. For example, remember the square root of 25 equals 5, because you're asking yourself what number when you multiply it twice equals 25. Or let's say if you had the square root of 16, the square root of 16 would equal 4, because you're looking for a number when it's squared will equal that original number. So in this case, I am looking for what number squared will equal negative 25. Well, you may think of, okay, well, we know it's not positive 5 because the square root of 25 is positive 5. Well, you might think, okay, well, it equals negative 5. Well, it doesn't equal negative 5 either, because negative 5 times negative 5 equals positive 25, and it still does not equal negative 125. So remember, a square root means you're looking for a number that when you square it equals that number under the radicand, and in this case is negative 25. The point is, there is no real number that when you multiply it twice or when you multiply it by itself, that will give you a negative 25. It just does not exist. So in that case, we just simply say that it does not equal a real number. Now in the future, you're going to find that you can solve that. It does equal an imaginary number, but it does not equal a real number. So in this chapter 10, anytime you see that, you can simply state the answer is simply not a real number. Now in section 10.7, once we learn about imaginary numbers, then from section 10.7 on, you will have to actually state what it equals, that imaginary number that it equals. You cannot get away with saying not a real number. But for now, up until you learn section 10.7, if you find the negative under the radical symbol, it is simply not a real number. So let's do some practice to see if you can differentiate between the negative on the outside versus the negative being underneath the radical symbol inside. So what is the negative square root of 81? Well, notice we have the negative on the outside. We have a perfect square root here, a positive square root. The square root of 81 we know is 9. But because we have that negative in front, we're going to negate our answer. So instead of 9, it's going to equal its additive inverse of negative 9. How about the square root of negative 49? So notice here we have the negative under the radical symbol. And whenever you have the negative under the radical symbol here, we are asking what number When we multiply it twice, will equal negative 49. There is no number when we multiply it twice will give us negative 49. Again, anytime you notice a negative underneath and it's a square root, you're just going to simply say not a real number until you learn about imaginary numbers. Moving on to the negative square root of 100. So here we have it outside. So you're simply negating your answer. We do have a positive square root. The square root of 100 is 10. But because it has a negative on the outside, that is why it equals negative 10. How about the square root of negative 64? If you said not a real number, that is correct, because there is no number when you multiply it by itself or square it that will give you negative 64. And lastly, the square root of negative 25 over 49. Again, you should note that this square root has a negative under the radical, so therefore it again not a real number.